Hello everybody. Now we're going to look at section 13.4, the definite integral, sort of like the meat of what we're doing in this particular section, or excuse me, chapter. First thing we're going to look at is some rectangles. Now, technically when we have the definite integral, what we find is area under a curve. So here's my curve. And the area I'm looking at is from the curve to the x-axis. One way I could do this is make a series of rectangles. Okay? Now the area of a rectangle is length times width. Well, if you'll notice, my height here, which I'm going to call my length, is going to be determined by a y value. Now these particular rectangles, they're all attached to the curve on the left-hand side. So this is called the left sum method. So if I know the curve and I can get this x value right here, then I can put that x value into my curve and find out how high my rectangle is. Now the other piece is how wide. Now I tried when I drew these to indicate that all of my rectangles have the same width. Every one of them have the same width. So if I find the area of the first one, find the area of the second one, then the third one and the fourth one, I add those up, then it will give me an approximation of the area under the curve from where I start here to right here. But if you'll notice, there's some issues. Do you see these little blank spots right in here? These are some values that I don't get. Well, now then if I come over and I do the same thing, I'm starting at the same place here, but if you'll notice, these rectangles are attached on the right hand corner. That's why it's called the right sum method. So if I do the same thing, but now this time I'd have to use this x value to find the height of this one, and I'd have to do that with the rest of them. My width is still the same thing, and if I got the area of the individual rectangles, then that will over approximate. This one under approximated, but a lot of times when I actually have problems that we do using rectangles, I'll do both of these methods and then add it together and get an average, because what's over here pretty much fills in the blank spot here. Okay, and it gives me a very good approximation. And we're not going to go and actually find the rectangles or anything, but some of the questions initially that you have will be, are they left-hand rectangles or right-hand? But the biggest piece right here is to approximate the area under a curve for a closed interval from A to B. We can draw a series of connected rectangles, and then after finding the individual areas of all rectangles involved, sum up those individual areas, and it does approximate the area under the curve from the curve to the x-axis. There are some special properties, 3 in particular, that I want you to see. This is telling me the interval. This value down here, called my lower value, that corresponds to the left. The upper one corresponds to the right-hand limit. But if I go from A to A, technically all I have is a line, and a line has no area. So if these two values, my lower limit and upper limit, are the same, there is no area involved. This piece right here, it tells me if my left value is A and I go to B of this function, but what I need you to see here is that they have reversed these values. You'll have an opposite answer. It'll be negative, or whatever the opposite is. So we do have to take into very, deep consideration, what are my limits, and am I going from left to right like normal, or have they reversed me going from right to left? If they have me going from right to left, then I'm going to have to take the negative of whatever I come up with for that particular area. Number 3 here will come into play in the let me see, not this section or the next section, but the section after. If they want me to find the area from A to B of this function, I can split it up, Now the C would be a 0 where it would cross, or another way you could look at it is where this one leaves off, this one picks up. Excuse me. But I'm going from A to C of this function, add on from C to B of the same function, and I will get that total area that they initially want me to do from A to B. I do need you to go to page 736 and look at figure 8 and also example 3. It helps a little bit more, but right now I'm going to go look at some of your homework with this. So these are problems 1 through 8. Let me look at these. So in these exercises, problems 1 through 4 refer to these rectangles, A, B, C, D, E. Okay? Which rectangles are left? Well, if you look at this, I only see 2. How about you? I believe C and E. Notice that they are attached on the left-hand corner. How about which rectangles are right? I choose A and D. Which rectangles are neither left nor right? Well, B is neither left nor right, so I would go with B right there. Which rectangles are both left and right at the same time? Well, there's none. None at all. Let's look at problems 5 through 8. Refers to these rectangles. Maybe problem 4 here will become more apparent here. So in 5 through 8, which rectangles are right? It looks like H and I. Which ones are left? That would be G and H. Which rectangles are both left and right rectangles? The only one I have would be H. Which rectangles are neither left nor right? Do you see them? There's 2 of them. They would be F and J. So those are those problems. I like those. Let me look at another one, because there's just so many problems I need you to do out of this section. I'm going to be doing the even ones. I want you to do the odd ones. I also have my calculator handy just in case. Now, first thing, they give me these areas. Okay, so area A from A to B would be 1.408. This area is 2.475. Now I need you to understand something here. Remember when I was talking about the rectangles, and in the rectangles you go from a value up to the curve? Well, if I had a little rectangle here, my y value would be positive. My width is always going to be positive. So I would have a positive area here. But I need you to think about drawing a little rectangle here. Just say right at B. If I do a rectangle here, my width will be positive. Say it's the width of this little hand. But if you'll notice, my height, because my y value is below the x-axis, will be negative. So technically area B right here would be a negative 2.475. That's why I wanted to look at those rectangles, for you to get an idea why this would be negative. C, going from 0 to C, would be positive, but D right here, going from C to D, my left-hand limit to right-hand limit, or lower to upper, because it's under, it would be negative. So technically, if I had the integral from C to D, it would be a negative 1.792. So here's this function. They want me to go from 0 to C, so my left-hand value is 0. They want me to go here, so it's referring just to C alone. Since it is above, my answer would be 5.333. That would be the answer for that one. Let's see this one, from B to D. So here's B. I've got to go all the way to D. Well, I have to do these in sections, so I've got to go from B to 0. So that's going to be a negative 2.475 because it's below. Now I've got to go from my 0 to C, which is C. It's above, so it's positive, so plus 5.333. and then to end up from C to D. So see, this has taken me from B all the way to D, so I can do these in sections, but it's below, it's going to be negative, so negative 1.792. So my answer for 28 should be 1.066. Let's see, from 0 to D, here's 0 to D. It's about the same thing as this without this, so let me do a little sneaky thing here. I'm going to do second enter to get rid of that, and let me just hit delete. We could have put the whole thing in, but I do like second enter. So my answer from 0 to D would be 3.541. Okay, 32, I'm going from D to A. Notice from D to A. I'm going from D to A. So I am going to do the exact opposite of everything as I go. Remember, if I go from right to left, it changes all signs. So from D to A, I have to go first from D to C. I know it's negative right here, but because I'm going in reverse, it's going to be positive. Looking at those examples, I think will also help. Going from C to 0, going right to left, I've got to do the opposite. Zero to B, do the opposite. So I'm going to have a plus 2.475. And then from B to A, it was positive, but because I'm going from right to left, it's now negative 0.408. So my area for number 32 is negative 2.474. Let's see, from C to A, very similar to what I had. If I can get rid of this piece, then I'll have it. So I'm going to go right back up. Let me do second enter. Let me go back, and I'm going to hit my delete. I think this would be faster for this particular one. Now C has got to be negative because I'm going from right to left. So let me hit enter. Whoops. Oh, because of that. Anytime you get an error message, always do a go to, and it'll tell you the issues. So because it's a lead off, it now has to be the little negative symbol. There's my answer. Negative 4.266. Let me see what my last one is. Gotta get my calculator back. They want me to go from C to B. From C to B. So which one can I get rid of? I have to keep C. I have to keep that one. I've got to get rid of this one at the back end. So let me delete. My C is going to be negative. My B will be positive. My answer, since I'm going from right to left, will be negative 2.858. So I need you to do these other problems, 25 through 35, and see how they go. And we'll be looking at the next section here in just a bit. Thank you.